Horizontal asymptotes. For rational functions, there are only three possibilities. So specifically three possibilities for rational functions. Now, other graphs can have other outcomes, but we only have three possibilities. For option one is you get the line y equals 0. Option two, you could have the line y equals a fraction where you have the, I'll say the a value of the top divided by the a value of the bottom. And when I reference a value, I'm specifically meaning leading coefficient. Of whatever polynomial is on top and the bottom. And then finally, you get no horizontal asymptote is your last option. So 3 options. And now we just need to know when to have those 3 options. Y equals 0 is whenever the degree of the top is less than the degree of the bottom. Now, when I say top and bottom, I mean the numerator and denominator, but I mean of the fraction bar. So basically, you have the top and the bottom will have a degree, like x to the second plus 5, and the bottom will be like an x to the third. It could be 10th, it doesn't matter, plus x squared, what have you. As long as the top degree is smaller than the bottom degree, then the answer, the horizontal asymptote, will be y equals 0. So there's a little example there for you. To have a different scenario where the a top and the bottom is the division of the leading coefficients, you've got to have the top degree equal to the bottom degree. And what I'm looking at there is a, say, x to the third plus x squared over a x to the first plus 3x squared plus 3x to the third. Would make these the same degree. The degree of the top is 3. The degree of the bottom is 3, even though it's out of order. So our job would be to take the leading coefficients and divide them. Well, the leading coefficient on the top of this one on that I made up right here is a 1. And the leading coefficient of this one is a 3. It's out of order. It's not in standard form, but it's still a 3. So the answer for the horizontal asymptote, say HA for short, is going to be y equals 1/3. So whereas the last one, the answer is y equals 0, this one will be an answer of 1/3, y equals 1/3. And finally, to have no horizontal asymptote, that scenario is when the degree of the top is bigger than the degree of the bottom. And so what that would look like is anytime you have, say, an x to the third plus 2 divided by, I don't know, x minus 5. So it is a linear function on the bottom and a cubic function on the top. What's happening is this top degree is 3, the bottom degree is 1. In this instance, you have no horizontal asymptote. Now, you do have a slant asymptote, and that's a whole different conversation, but this is the basics for what it looks like to decipher between your 3 options just regarding horizontal asymptotes and rational functions. So to decipher what our horizontal asymptote is for this problem, or any rational function, first thing you look at is the degree of the numerator and the denominator. Both of these happen to be in standard form. And the numerator degree, so I'm going to say deg top for degree of the top, degree of the numerator, is smaller than the degree of the bottom. I'm going to say deg bot for short. Anytime you have this instance where the degree of the bottom is bigger, immediately the answer is y equals 0. No more work is required. That is the answer for the horizontal asymptote. And so all I did was sort through my list of 3 options. I identify the degree of the top is smaller than the degree of the bottom, and immediately the answer is y equals 0. That was it. When we're looking at trying to find a horizontal asymptote for a rational function, the first thing we look for every time is the degree of the numerator, degree of the denominator, and then we compare. Well, this time the degree of the numerator, I'm going to call it degree deg top for short, is bigger than the degree of the bottom. So the degree of the numerator is bigger than the degree of the denominator. And so if I'm just quickly sorting, I know that it's this instance over here where there is no horizontal asymptote. So my answer is immediately no horizontal asymptote. And at this instance, I'm not concerned about the slant asymptote that is there. I'm just deciphering there isn't a horizontal asymptote. So in this instance of our rational function horizontal asymptote analysis, we've got a degree in the numerator that's 2, a degree in the denominator that's 2. And so quick analysis says those are the same. So degree of the top is equal to the degree of the bottom. And so our instance is a little bit more complicated. This is the most complicated type. When the degree of the top is equal to the degree of the bottom, I'm supposed to divide my leading coefficients. The a top divided by a bottom for short, but a, of course, means, and I intend it to mean, leading coefficient. So we come to the problem, and we divide by our a values. So the leading coefficient of the top is 4, leading coefficient of the bottom is 5. So the horizontal asymptote will be y equals a top, which is 4, divided by a bottom, which is 5. Leading coefficient of top over bottom is just 4/5. So the line y equals 4/5. The horizontal line is where this function heads as we go to infinity, infinitely left, and infinitely right. So here when we're looking at rational functions that are in factored form, it's a little bit harder to decipher what the degree is. But to do this, all we need to do is count the x's. So if I'm paying attention, I'll see I have 1x here. That is a degree of 1. Even though it's not distributed, it is a degree of 1. That's the numerator. That's the top. And then on the bottom, we'll see that we have a degree of how many x's we have. If I was to multiply this all the way out, the degree on the bottom would have been 2. And so comparing it this way, I see the top is smaller in degree as compared to the bottom. So in this instance, anytime the bottom degree is bigger, on our sorting chart, we'll see the answer is always y equals 0. So as soon as I identify the degree of the bottom is bigger, y equals 0 is my horizontal asymptote. It means as I go infinitely left and right, the bottom gets bigger faster, and it squishes the function to be heading toward the x-axis as you go left and right. Now in this example, we have another factored rational function, and so our job is to figure out what the degree of the top and bottom are. So the degree of the top can be quickly found by counting the amount of x's I have. So I have 1x, 2x on the top, which means my degree of the top is 2. Divided by, on the bottom, I just have 1x, and so that'll tell me that the degree of the bottom is just 1. So we just discovered the top degree is bigger than the bottom degree. And so the instance when the top is bigger than the bottom is that there is no horizontal asymptote. So our answer is that there is no horizontal asymptote. There's actually a slant asymptote. That's a discussion for later, but no horizontal asymptote. Now, if you see perhaps that this could reduce down, that's something that we'll talk about later. You still have a linear function, which is actually what the graph looks like. The linear function answers the question that we have no horizontal asymptote because the graph is going up forever to the right and down forever to the left. And the horizontal asymptote we're looking for is discussing a horizontal end behavior. And this is not heading horizontally, it's diagonally, heading up and right. Now we get a little more complicated here where the degree of the top and the bottom are going to be the same because I have 2 x's on the top. So the degree of the top is 2, and the degree of the bottom is also 2. This problem is a little bit troublesome. It's not terrible, but it's still troublesome. So the degree of the top is 2, degree of the bottom is 2, so top equals bottom degree. So what that means for us is we're supposed to take the horizontal asymptote as the a value of the top divided by the a value of the bottom. And what I mean by that is your leading coefficients. We have to be careful because we don't see these in standard form. We have to imagine what it would look like to get to standard form. And so there's either you don't imagine it and actually distribute and FOIL and distribute that 3 in there, or the easiest way to do this is just focus on the x's and their coefficients and the 3 out in front. If I was to multiply these x's together and the 3 and the 3, this would turn out to be 9x squared on the top. I could get the whole thing, but I just have to focus on the 3 times the 3. And then if there was a number over here in front of this x, but there isn't, so I just focus on the 3 times the 3 right here and this 1. So really the 3 times the 3 times the 1 is my leading coefficient of the top. So that's 9 over the leading coefficient on the bottom is 2 times this 1 times this 1. You don't worry about the 6. You don't worry about the -1. It's just worried about what's in front of those x's and the very front term. So it's 2 times 1, which is a leading coefficient of 2. 9/2 is your horizontal asymptote. Y equals 9/2 is your horizontal asymptote in this particular instance.